How do you follow that? I've never been able to run, let alone 90 kilometres an hour. Challenges. Phytosanitary treatments going forward and addressing that challenge. And I was thinking about it. Title is 377 days. That's the amount of time we've got before the 2020 deadline arrives for not being able to release methyl bromide to the atmosphere. I need to clarify with the EPA whether it's at midnight on the 27th of October next year or the 28th of October. It might just buy us an extra 24 hours. But if we think we've got problems, think about poor old Boris. He's got 15 days. So this has really been driven by this decision of the EPA in 2010 and a need for alternative phytosanitary treatments. We've invested a significant amount in research to try and resolve this issue, and the outcome really is around sustainable treatments for our exports and for our own biosecurity. Can't be that difficult, can it? We currently treat about 6 million tonnes of logs, predominantly radiata, that go with methyl bromide each year. So it's around 30% of our export volume. It's our entire trade with India, and it has a value of somewhere around $750 million a year to the New Zealand economy. So it is quite significant. It's driven not by our desire to fumigate or to carry out any phytosanitary treatment. It's driven by our trading partner demands. And it's exactly the same as New Zealand. We require clean products imported into New Zealand, and our trading partners expect us to deliver to them clean products. And I think it's really important that we all understand that this is driven by trade and politics a lot more than science. And you know, we're currently, MPI in particular, are doing a lot of work around brown marmorated stink bug, and you'll say, well, what's that got to do with forestry? The issue is if we get an establishment of BMSB in this country, some of our trading partners are simply going to say to us, well, actually, we don't want your logs because they may bring stink bug to our country. So the stink bugs won't bother the logs, don't even bother forestry, but they bother trade. And that's the real key driver, and we should never lose sight of it. So the journey to finding alternative treatments, it's pretty straightforward. It's a bit of a walk in the park, really. Biggest challenge, a little bit of rough, and maybe the odd dog turd left behind, but nothing particularly serious. And we started this journey back with the EPA decision in 2010, where, and contrary to what some people feel, this is not a ban on the use of methyl bromide. It's a ban on releasing methyl bromide to the atmosphere following fumigation. And while the log export industry is by far the biggest consumer of methyl bromide, the horticulture sector is also part of it as a requirement for exporting apples into Japan. And MPI are also users of methyl bromide to protect our borders when people bring consignments of products that may be infested with something we don't want. And all of those sectors are captured by this requirement to recapture methyl bromide following fumigation. So, you know, it can't be that difficult, bit of a walk in the park. I guess the realistic expectation was perhaps there was the odd prickle bush, maybe the odd rock to trip over, but again, nothing too daunting. So what are our options? And speaking particularly about the log export trade, the vast majority of logs that go to China are treated with phosphine. Suffice to say that we've maxed out the amount of phosphine we can use. As an industry, we would use more phosphine if it were possible, but it simply isn't possible, and that's driven by space on ships. Phosphine is in hold use only, and it is by far and away the cheapest, so there's no reason that we wouldn't want to continue in maximising the use of phosphine. So the idea that we could use phosphine as an alternative to methyl bromide is one that simply doesn't fly. Through our work, we felt that we needed to look at non-fumigant treatments, and we spent quite a long time looking at whether there was an ecological approach to using something other than methyl bromide. We wanted to look at alternative fumigation options, and we wanted to look at some other potential treatments. So the alternative fumigation options, we came up with EDN, which is a relatively new chemical. Well, it's not a particularly new chemical, but it's newly recognised as having extremely good phytosanitary capability. We applied for registration, we as in MBr and the industry and the manufacturer, Draslovska, applied for registration of EDN in July 2017, and as you note, no outcome to date, and would actually say that we've got no visibility over an outcome from that process. So you start to panic after a couple of years. You think, well, we should have had EDN. We figured we had 3 years. That would give us time to get registration. It would then give us time to get domestic resource consents, and most importantly, time to socialise it with our trading partners and get their acceptance of it, because ultimately it comes down to their acceptance of phytosanitary treatments, not what we think is best. So we've completed industrial scale confirmatory trials. We know it works. We've reduced the dose rate as a result of that. We originally applied for 150 grams per cubic metre. Our confirmatory trials, industrial scale trials, 400 JAS log stacks, confirmed that 120 grams was more than enough. So apparently that requires a new application because we want to use less. It is just a bizarre system. We've also looked at how do we continue using methyl bromide, so looking at lower rates of methyl bromide to achieve the same level of phytosanitary treatment, and seeking to methodologies for recapturing methyl bromide. But as we run out of time with the EDN registration, we have also applied for a reassessment of the 2010 decision and seeking to recapture 80% of what's left in the headspace. So that's the gas that's left behind after the completion of fumigation. And even 80% is quite a significant challenge. In a purely chemical and scientific manner, it's just a very difficult thing to recapture and dispose of. And more recently, we've been looking very hard at a judicial review of that 2010 decision because we're not convinced it was suitably based on science. So EDN, very quickly, it's a gas at room temperature. It breaks down in the presence of water, fundamentally to carbon dioxide and ammonia products. The manufacturer, Draslovska, a Czech company, have been very strongly supporting the research and have put a lot of money into it, and are ensuring the supply chain is in place so that we can actually move to it as soon as that option becomes available to us. One of the critical things is that following fumigation, there's less than 1% of the applied EDN remains in the headspace. So the 99% of it is actually physically or is chemically broken down to carbon dioxide and carbon dioxide and ammonia products, which suggests there is no need to recapture because there's nothing there to recapture. But that's something that we're still working through with the EPA. We also believe it should be suitable for ship holds, and that would have a huge benefit if we were able to convince the Indians in particular that we could use EDN instead of methyl bromide. We could actually do in-hold fumigations. And we're working with WorkSafe to develop the safe work instruments that are now required under the new legislation to ensure not only worker safety but public safety and so on. So there's quite a lot of work going on and has gone on in the background. As I noted, we can we can achieve the same rates of fumigation or phytosanitary control of insect pests with significantly lower rates of methyl bromide. So in some cases, less than 50% of the current dose rate will still achieve the same rate of, same rate of phytosanitary treatment. You know, I put it slightly differently. You can only kill them once. You can't kill them twice as dead. So we believe that 80% recapture is what we can achieve, but we need a lead time to achieve that because we've got to build quite a lot of capacity in terms of recapture units. And it's really required until EDN is accepted by our trading partners and by our own regulatory authorities. So Fumigant Research, from Stimber's perspective, we believe that there's not too much further research required around fumigants. We know these things work. We've got the efficacy data sets. We don't believe we should be investing too much more in that space unless there's specific questions got to be answered. Very much into the implementation, registration, regulatory phase. But we're also continuing with long-term non-fumigant research. Let's be honest with ourselves. The days of just using chemicals to fix all our problems, and we've heard that yesterday and again today, we need to think very carefully about that approach to the long-term future-proofing of our business. So we're continuing with non-fumigant research, particularly dual heating at a low level. We're working with our two key trading partners, being India and China, around both acceptance of EDN and lower rates of methyl bromide. The Indians in particular have a concern about Cyrex, and most of that goes back to a paper that was published, I think, in the late 50s or early 60s, and unfortunately they've still got a copy of it. And so they keep quoting it to us, and how many people in this room have ever seen a live Cyrex in the forest? 1, 2, skites. So the issue is we don't have a problem with Cyrex. It's almost impossible to find, but convincing the Indians that we don't have a problem is a different issue. So really, just to wrap up, we've completed a very robust and comprehensive research program. Collectively, not just Stimber, but other sectors have invested somewhere in the order of $30 million over the last 10 years trying to resolve this problem. It's not a simple challenge that we initially thought it would be. We're certainly leading the world in the space of recapture and in alternatives. There's been vast numbers of publications, and that's really quite important because we can then point our trading partners to the science that's been published in globally reputable journals and therefore support our case that we haven't made this stuff up. There's very strong trading interest from our trading partners, but I guess I have to own up to the fact that I grossly underestimated the difficulty of getting through our own regulatory regime in New Zealand, and I heard that from somebody just a little bit earlier, the difficulties of getting registration of CRISPR technology, those sorts of things. It's an ongoing challenge for all of us involved in that sort of science. And as I said before, we are continuing with some non-fumigant work. The reality of the journey, as I said before, was I thought it would be a walk in the park, maybe the odd prickle bush or the odd matagari bush and the odd rock. The reality is that we didn't see the mountain in front of us. It's rather substantial. There's some significant ice cliffs there, and what's more, we've got no idea what's on the other side of it. And really just acknowledging the vast amount of support from industry, from Stimber and FOA boards, our science providers, particularly Plant and Food and Scion, University of Canterbury. MPI have been very, very important in this journey, and Draslovska, Genera as our key fumigator, and we've had financial support from the bottom too, so appreciate your time.